unfortunate that they don't reprint it for you anymore, but they don't. Alright, so as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. It's an e. Okay, remember, like an absolute value kind of for the most part behaves as an even function. Technically it's not, but it kind of behaves that way. Alright, y'all okay there? Alright, this one.
Horizontal stretch by 4.
Okay, f of x equals x squared, h stretch. It's inside, so I've got to flip it over by 4. Okay, so x squared has a vertex here at 0, 0. So basically my first, if I choose 1 times 1/4, 1/4 squared is going to be 1/8. That's not going to be nice. 4. 4 times 1/4 would be 1. 1 squared would be 1. It's supposed to be right here. So it'll be the same thing on this side. If I choose 8, because 8 will cancel that 4, will give me 2. 2 squared will be 4. So 8, I'm at 4. Same thing at negative 8. And that's all that's going to fit on this graph. So it's a very wide. Okay, so this is where, like, it's probably a good function to kind of talk about this. So it's a horizontal stretch. So remember, for stretching, we're trying to get closer to. Because it's horizontal, it's trying to get closer to the horizontal axis. But it looks the same as a vertical shrink, because a vertical shrink is trying to get away from the vertical axis. Does that make, y'all remember that? Yes? Alright, make sure y'all are right. Okay, domain here. Reals, range.
X or y is greater than or equal to 0.
Okay, x and y intercept are both at 0 here. Alright, extrema has an absolute in at 0. Alright, it decreases first, so I'm gonna write it decreases from negative infinity to the x value of 0, and then increases from x value 0 to positive infinity. Alright.
Okay, on those ones, are we supposed to have a bracket?
Do what, baby?
Do we do the bracket on those?
I'm not gonna, I don't really care one way or the other. The only time it really mattered that I'm kind of like particular about it is when we have like holes and stuff like that. But a lot of times I write them as a parentheses. So if you write as a bracket or parentheses, I don't really will get you on that.
Okay.
I mean, a college algebra instructor might. It depends on how particular they are. Alright, as x approaches infinity. So if you drew the bracket, leave it. If you didn't, don't worry about it. This is the squiggly one. Alright, so transformations, I've got a
Stretch
by 2, BT, down 5. Alright, so x cubed at, let's see, 0, huh? Yeah. And then 1's gonna be negative 3, yeah? Which means negative 1's gonna be right here. Alright, 2 cubed is 8, 16 minus 5 would be 7. 2, 3, 4, 5, 6, 7. The other one's not gonna fit. That's all that's gonna fit on there.
Where did you get negative?
Huh? I did it in my head. Negative 1 cubed is negative 1 times 2. Okay, I am right, yes?
Yes.
Okay, so I did it in my head, so, you know, sometimes I do mess up. Alright, this one is not gonna have an x-intercept that's nice, so we're gonna get out of the calculator.
2, 11 in the calculator.
2 and 11? Oh, 16 minus 5, 16 minus 9. 3. Okay, alright, that's what I did. Alright, domain and range, both all reals there. And x cubed has no extrema. Y-intercepts at -5, so we got that one. X-intercepts, anybody, did y'all get any calculator, anybody? Is it, it could be 1 and some change. Ah.
I got 1.35720888.
1.36. Got it. Okay, increasing is gonna be negative to positive always. Decreasing is not happening. So none, never, whatever interesting way you wanna write that. Alright. As x approaches infinity, f of x approaches infinity, x approaches negative infinity, f of x approaches negative infinity. Good there? Questions on that at all? Everybody okay? Got it? Alright. It's a square root function. F x. 3 outside is gonna be a stretch by 3. Aren't you glad we don't have to write all that out? Y-axis reflect. And then I've got an h t to the right. 2. Okay, so let's see, square root would normally do this, it's reflecting it's gonna go this way. Ooh, lots of stuff going on there.
It's gonna be 2, 0, is the first one. Right?
Yeah.
One is at positive
And it
3.
should come this way, yeah?
Wait, why is it not +2?
Didn't it come this way?
Yes, ma'am, it does.
Okay.
But it's still +2.
Positive 1 goes to positive 3 and 0, or 2, positive 2 is at 0.
No, because it becomes a +2. +2 is at 0.
Oh, it went to the right too. I did that wrong. Went to the right too. My fault. Sorry. Went to the right too. Sorry. Alright, so
It's
then
1, 3.
1 and what, 3?
-2 and 6.
Negative 7 and positive 9. And that's all we can fit on the graph.
-7 and what?
Positive 9.
Alright.
Stupid. All you have to do is dang. Oh, we don't.
Alright, y-intercept you can get from your table, x-intercept we can see. So x-intercept's 2, 0, y-intercept, anybody where x is?
X is new.
Go to x is 0 in your table, what's y?
4.2426.
Oh, good.
2, 4, okay. Alright, domain is,
Looking at the other way.
x is less than or equal to 2 there. Range y greater than or equal to 0. Feel okay with those?
Yes, ma'am.
Alright, extrema, it has an absolute min at 2, 0. It never increases, none, never, whatever, decreasing from negative infinity until 2. In behavior, as x approaches 2, f of x approaches 0.
Wait, we're not doing infinity? Oh, wait, never mind. I figured that out.
Yeah, it can't because it has a distinct point here. As x approaches negative infinity, f of x approaches infinity. So there's your infinities thing. Y'all okay on that one?
Yes, ma'am.
Alright. Okay, this one is a cube root function. Cube root of x, so it's gonna be a sideways squiggly. Alright, so we've got a h shrink by half. We have an ht to the left, 1, and a vt up 4. So that means, so that 1 and 4 is gonna be where my point of inflection is. -1, +4. Should be where it
So
kinda curves.
will there be a dot on either side of it?
Huh?
Will there be a dot on above?
That 2 is gonna affect that.
Okay.
Like that 2 is gonna affect where that goes. But if I plug 0 into this, I would get +4. So at 0, it's gonna be positive. Wait, did I put that at the wrong spot? No, it's not gonna be 4. Wait,
It'll be
thank
5.2599.
you.
At -1, it's +4.
At 0, it's what? Say that again?
5.25.
And some change. Okay, so somewhere in here. Alright, 1, what'd you say? What number?
At -1, it's +4.
Yeah, I got that one, cause that's your inflection point. That I got from here.
At 3, it is, or, yeah, at 3, it's +6.
Okay. Anything on this side at all?
-5 is +2.
Probably all that's on there.
Yeah.
Okay. So something like that-ish. Okay, domain and range both are reals for this. X-intercept, we'll have to go calculate that somewhere. It's way over there. Y-intercept, Casey, you said it was at 5.2.
Two something.
5.259.
Okay.
So, yeah.
Your y-intercept, you can scroll down it's gonna be negative. So
Hold on, I'm getting there, it's just taking 10 years.
yeah. Where are you at right now?
Hold on,
30, -30.
I'm almost there. It is -33 and 0.
Alright, got it. Okay. So extrema, there are none. Increasing, negative to positive, never decreases. Alright, end behavior as x approaches infinity. F of x approaches infinity. As x approaches negative infinity. F of x approaches
Yeah, I was waiting on
doing
that.
that.
Well, because you didn't know that I was gonna be, it was gonna be perfect.
Okay. Y'all all good with that one?
Yes, ma'am.
Alright, this is our reciprocal function. Definitely gonna have to graph this one, cause I don't know these well enough. And I don't have where I'm gonna asymptote here for sure. Horizontal and vertical.
Okay,
Okay, I mean, I know it's reflected, so normally these would be in these quadrants. But there's reflection, so these quadrants. Cause that's an x-axis reflect. The 4 is a vertical stretch, cause I could separate it out. Be stretched by 4. And then the 3 is gonna be an h, t to the left 3. So normally I would have a point right here, if I reflected it would be here, and now it's gonna go to the left 3, 1, 2, 3. So now I have a point right there.
-3 is your asymptote.
Which vertical or horizontal?
vertical. Horizontal is 0.
Oh, yeah. Yeah, that's what that number represents. This is gonna give you your asymptote right here.
Your y-intercept
Wait.
is
was saying there'd be a point here, but the stretch by 4, like I forgot
There's
about
a
that.
1, -1.
What is it?
1, -1.
Alright, that's probably it.
Negative 4, 4 on the other side.
There's.
I have -2, 4, or -2, -4.
Negative 4 and 4, you said?
Yeah.
Oh, yeah, cause it matches this side.
And then negative 5 and 2. And negative 7 and 1.
Is there like a specific amount of points you want us to have on it?
I mean, if they're nice, we need to have it, if you don't have any nice ones, probably 3 for those curves, like, if they're nice points, like you can get whole number points, get them. You know what I mean?
You're gonna have X does not equal 0.
Or, yeah,
X does not equal -3.
yeah, then the other way is Y doesn't.
Y is not equal to 0. Here's the deal with the domain, with a reciprocal function, whatever would cause this to be undefined, that's gonna be your asymptote.
So
Alright,
it would be-
x-intercept, there won't be any,
It'll be -3.
so that's why it's out of the domain, cause your that would cause you to have 0 in the denominator, so it's undefined there, that's where the asymptote is. Okay, extrema, there are none. Alright, so this one, as I come this direction, it is increasing from negative infinity to the asymptote. So, negative infinity to -3, then it picks up again on this side of -3, and it's still increasing. So, -3 to positive infinity, it does not decrease at all. Okay, there.
Dragons.
Huh?
Nothing dragons.
Absolutely not.
Is it?
No, cause it doesn't touch -3 at all, so it can't have a bracket. Alright, any behavior, what'd you say, Riley?
So it's a union, maybe?
Yeah, it'd be in there. Alright, as x approaches infinity, f of x approaches that horizontal asymptote, which is at 0. As x approaches negative infinity, f of x approaches that same horizontal asymptote on the other side. Three, 4, distribute to your friends. Okay.
Oh my goodness.
Alright,
Oh, 2 notes?
yep.
Oh.
Okay, here we go. So parent function here is cube root of x. So another sideways squiggle.
Y-axis records.
Mhm.
Horizontal stretch by 3.
Mhm.
Vertical translation of 4.
Okay, so the VT up 4 is what's gonna move me from 0, 0 up here to 4. So I know that's my inflection point. Other than that, I don't know anything. Well, I do, it's reflected, this, it's a horizontal reflection, so instead of coming up this way, it's gonna come down this way, I know that. I don't know anything else besides that. I'm gonna choose 3 though to make things nice, cause 3 times 1 would be 1, so cube root -1 is -1. Plus 4 was 3. So at 3, I'm at 3,
And at -3 you're at 5.
and I bet that's all that's on the graph.
At 9, you're at 1.
Positive 9? Is it 1? Okay, what about -9?
No, wait.
Is it off the graph?
It's like 5.4422.
Oh, it's ugly, okay.
Oh shit, what the heck?
Wait.
Wait, I put something in wrong, cause I.
Yeah, negative, or positive 9's at 2.55.
2.55, oh, that's decently, okay, 2.55, about right there.
Wait, I thought we got +9, 1.
Zane had it, he said he had
I put the 4 on.
-9 was it, where'd y'all say?
Like the same thing.
Ish, about here. 1, 2, 3, 4, 5, 6 and some change?
it was 5. It was like 5.
5 and some change, okay, there, okay. Alright, so something like,
Mine looks a little wonky.
yeah, mine looks pretty wonky too, so it's alright. Alright, domain and range, both all reals there. X-intercept, oh my gosh, it's gonna be huge. Okay, wait, hang, I'm gonna give it to you, I'm gonna find it. Yeah, it's huge, 192, big number, huge. Alright, Y-intercepts
You like doing
at 0 and 4,
I was having fun.
no
that? You know what?
extreme. Alright, increasing, not at all because of the negative, so it is decreasing from negative to positive. In behavior as x approaches infinity, f of x approaches negative infinity, as x approaches negative infinity, f of x approaches positive. There. Alright, this one is reciprocal. X equal to 1 over x. Okay, just so y'all know, like this right here, I could separate this and write this as 1/2 times 1 over x minus 1. Y'all do know I could do that, right? Like I can separate that denominator that way. Okay, so because of that, that 1/2 is vertical. Does that make sense? So it's a V shrink by 1/2, and then I have a VT down 1. Okay, so the parent function normally has an asymptote right here at 0, 0. I just shifted the whole thing down, so I now have one at -1. And it has a vertical at 0, and we didn't move left and right at all, so it's still right there. Everybody okay there?
All of my Y's are fractions.
Yeah, that doesn't surprise me. Okay, so I know the domain cannot be
It's negative, it's positive 1 and 1/2.
0. It's positive 1 and 1/2, you said? Okay,
And
and
then
then there's nothing else over there.
I have -1 and -3/2, if that helps. So like -1 and 1/2. Just like give you a
Negative
reference.
1 and 1/2?
The other
Negative
two.
1.5 here.
Yeah,
Okay, sorry.
and then the rest of them are ugly.
And I think your y-intercept's it's at half, I believe. When this graphs, does it even show your lines continuing, or do they stop on your screen?
They stop.
Yeah,
It says that there's an error at 0, or at your, for your y-intercept.
yeah, 'cause there's not one. Sorry, yeah. I meant x-intercept, sorry. Yeah, there's not gonna be a y-intercept because of the asymptote there. So it doesn't, sometimes my brain don't say, don't cooperate. Alright, so y cannot be -1, cause that's where my asymptote is. X-intercept is at 1/2. Y-intercept doesn't exist. Extremas, there are none. Alright, this is decreasing only, so there's none here. Decreasing from negative to 0, negative infinity to 0, and then 0 to positive, cause that's where my vertical asymptote is. And behavior as x approaches infinity, f of x approaches -1. And as x approaches negative infinity, f of x approaches also -1.
I'm getting tired of this.
Miss the days when they just had little blanks in there.
I'm not even getting tired of writing it, I'm just getting tired of graphing.
Baby, we're gonna be grabbing a whole year. Alright. Parent function here,
Absolute
f of
value
x
of x.
equals
Absolute value of x.
absolute value of x. Alright, so 1/4 is a v shrink. Make it get fat. Then I've got a h t to the left 2, vt up 5, so there's my vertex at 2, 5. That's also gonna be my absolute min. Alright, it has a slope of 1/4.
Hey, Miss Dog, is it not -2?
What? Oh, crud. Yes, it is -2. Cause I said to the left and I didn't do it. I to the left 2 and then 5. Alright, there it is. Alright. Alright, then I've got a slope of 1/4, so 1, 2, 4. Very wide absolute value. Should look something like that. My line's a little crooked, but you're right. Okay, domain all reals, range, greater than or equal to 5. Ooh, x-intercept, probably not nice.
Isn't there none on the x-intercept?
I mean, sorry, y-intercept, yes, none.
Y-intercepts 0 and 11/2.
Perfect. Okay, increasing from, what's that, -2 to infinity, decreasing -infinity to -2. Alright, as x approaches infinity, f of x approaches infinity, as x approaches -infinity, f of x approaches infinity. We could probably just not even do notes, I could just do the assignments.
I think so too.
But like, you don't need notes and you don't have to ask questions, right?
I use my notes. So I make good grades in my papers.
The only thing is the back two, we're gonna need the notes for.
Alright, there we go.
I didn't even.
I use that.
Alright.
Already.
These are, those are actually like, they're pretty easy.
I was working on
F of
secret.
x
I
is
didn't
equal
finish
to
this book.
x squared. Alright, so I've got an x-axis reflect. I've got a v-stretch. 3, I've got an ht to the right 4, and an et up 6. So that is gonna be my vertex at 4 and 6.
Point. Oh yeah, it is not like this. Or actually.
And that's gonna be an absolute max because of the reflection. Four, 6. Okay there?
Yes, ma'am.
Okay. Right.
Positives, or, yeah, +2's at -6.
+2, -6.
+3's at +3.
3 and 3.
5
Means
is at,
this is 3 here,
yes, ma'am.
and this is gonna be -6 here.
Yes, ma'am.
Like that. Okay.
Hold on.
So those x-intercepts are not nice.
It's at -42.
Oh, the y-intercept,
Oh, yeah.
is it -42?
Yes, ma'am.
Okay, x-intercepts are gonna be decimals. So yeah, we're gonna have to calculate those in decimal, cause they're ugly.
Second 3.
So, let's make it the left side, someone the one on the left, somebody else the one on the right.
I got 2.58 on the left,
158, okay,
and then on the right I got Oh my gosh. Second trace, 0. Enter. 5.414. So 5.4.
Works for me. Okay, alright, got that. Alright, increasing negative infinity to 4. Decreasing 4 to positive infinity. Here, as x approaches infinity, f of x approaches negative infinity. X approaches negative infinity. F of x also approaches negative infinity. Alright,
I'm not ready, don't
Yeah,
move.
for a
I'm not moving it.
I don't know if you can.
Can you put these in your calculator? Go to,
11 to 12?
I think there's a way.
aren't they the ones that are right there
Oh
above
my
the
gosh.
parentheses?
Miss Doc, the little exclamation points are in the calculator, so we can use that for calculator applications?
You talking about for factorials?
Yes.
Yeah.
Well, let's see. Oh, I
In the
see.
math menu. Let's
So
see.
now I'll give you 12 exclamation
It's,
points.
I think it's this one. It's gonna be number 5. I'm pretty
Okay.
sure. We're gonna try it with number 5. Pretty sure that greatest integer is number 5 in your go to math, go over to number, go down to number 5. I'm pretty sure that's it.
Okay.
Man.
Okay, so parent function is greatest integer function.
Oh, it is.
Okay, that's what I thought it was.
Is it?
Alright,
Like
so
this
we've
one?
got a
pretty cool.
H2 to the left one and a
How'd you do that?
VT down 3.
Put the thing in.
She just put.
Alright, so it's really not gonna make a huge ton of difference for this particular one because there's no shrink or stretch or anything. So it's gonna look the same as the parent would, really. So at 0, 0, there should be a point and it goes over and there's an open circle here, right?
Not at 0, 0. At 0, -2.
Okay, oh yeah, cause it goes down. Sorry. -2?
That's what it says.
Okay.
And then at 0, +2.
Okay, so at 0, -2, there's a point,
Yeah.
okay? So then it comes over and is there an open circle right here?
It doesn't give you circles, they're lines.
So let me see your calculator. I've never done these in the calculator, I've only ever done it this way.
Is there not a point at negative 1
Okay, okay. Alright. So this, on this right side, that needs to be an open circle there. So this one's filled, left side's here, that's there. Open here.
Are you counting each of your boxes as 2? I'm assuming.
So this is 2, this is -2, this is -4, -6, -8. Are there nothing on the odds case? You didn't even look.
I can.
Look at like at x is 1, x is 2, x is 3.
X is 1, x is, or -1 is -3, and 3 is +1. Am I being clear?
No, just hang your calculator.
It's all of the same, it goes, just add 2 to all of them, or subtract 2. I'm sorry, I'm being.
What I'm checking to see is if all the y values are covered. They are. So if 0 is here at -2. Yeah, that's straight. You don't need to do these by 2s. It doesn't matter. It's gonna look like this. Yeah, it's just normally we'd start here at 0, 0, but we were shifted
So we just follow whatever our calculator says?
Hang on, let me look at something real quick. Yeah, I mean, like, you're not really gonna have to deal with these hardly at all, so. I just want you to kinda get an idea of what it looks like. On these, like, the only thing, the main thing with this is I want you to be able to identify the transformations, cause they're the same regardless. So I'm not super concerned about the graph. Okay, so like, we're not even gonna do all of this for this, and you're not gonna be responsible for that, for these functions, like any of this part. The only thing mainly that I'm gonna want for these functions is this part right here.
Yes, ma'am.
So like, when we do 12 down there, like, we're not even gonna graph it, we're just gonna do the transformations.
Oh,
Alright.
thank the Lord.
That's all I need you to do on those. So you will not have to graph these, you will not have to do this stuff for these.
Yes, ma'am.
Transformations, yes, but not the other part. Alright, so,
X-axis reflect.
V stretch by 2.
mhm.
HT to the right.